Yeah, so hello everyone. I'll be discussing problems on phase diagram in this particular video. There are two types of problems under problems of phase diagram, type 1 and type 2. In this video, I will be discussing on type 1. Okay, and um, this is like under both the types, type 1 and type 2, I will be discussing just one problem each. Similar problems are there in your slides, so please follow the slides also. Okay, and if any other doubts, definitely we will clarify about that also. Okay, so let's start. The solidus and the liquidus temperatures for the alloy system containing two metals AB, which are completely soluble in liquid and solid states, are present in the table below. This is the table. Metal A melts at 1080 degrees Celsius and metal B melts at 1450 degrees Celsius. Now I'm supposed to construct the phase diagram for this and predict the number, type, relative amount and composition of phase present in the 60% A, 40% B composition at 1250 and at room temperature. So the second question has two further subdivisions, 1250 and room temperature. Okay, so how a phase diagram is actual phase diagram is constructed. So let's get back here. As usual, you will draw the x-axis which has the composition. There you have to, and since it's metal A metal B binary phase, you have to be particular that you have 100% A 100% B on either side of the graph. You can make it anyway, either first line you make it B, second line you make it A, it's up to you, but make sure you have 100% of A 100% of B. This way of representation is much easier because with this sort of representation you can easily solve the problem also with the graph. Representing, understanding, everything is easier. I mean, it's up to you, it's your wish. Okay, so let's start. Now with these points you have got the intermediary points. If you can see this arcs here, the small arcs, it is from this particular table, and the end points are the melting points. Okay, so this 1080 and 1450. Okay, my y-axis I have temperature, that is as usual, and I have mentioned 1500 degrees Celsius. Usually make it at least 20 to 50 degrees Celsius more than the given melting temperature. Okay, it's better because it looks neat and you can easily plot it. Okay, the plotting points are all will be easier. Okay, so the 2 points you have got, and then you have got the intermediary points. Now see, 90% A means it's nothing but 10% B. 60% A means 40% B. 20% A means 80% B. It's a binary phase. So this much percentage of A is there means the other percentage will be B. And with this temperatures, 1100 degrees Celsius, solidus, liquidus temperatures, you can easily get the points and you can draw it. Get it? So this is the basic graph that you get, and please mention the scale. Without mentioning the scale, you will simply lose marks. Okay. Then your graph is completed. Now you are supposed to predict the number of the phase present for this composition at 1250 degrees Celsius. Now 60% A, 40% B at 1250 degrees Celsius means the number of phase present is in this point M. 60% A, 40% B, 1250 degrees Celsius. The point comes at M. That means it is both liquid and solid. Why? Because the point is in the region between liquidus and solidus curve. If you have seen my previous video, the region between liquidus and solidus curve will have both liquid and solid. So this is the phase. These are the two phases present at this point M. So what are the number of phases present means it is 2. Type of phases. What are the type of phases present at this point M? As I told you, it is liquid and solid, the intermediary region. So the type of phases are liquid and solid. Next is relative amount of phases present. How do you find out the relative amount of phases? First of all, what does it mean? It means that you are supposed to find out how much amount of liquid phase is present and how much amount of solid phase is present at this point M. I told you it has both liquid and solid, but how much of liquid and how much of solid? So for that, you're supposed to apply lever rule. This also I have mentioned about lever rule in my previous video on interpretation of phase diagram. Please refer to that and get back to this. Okay. So by lever rule, I will get the amount of solid phase from the liquidus line, and I will get the amount of liquid phase from the solidus line. It's the opposite direction. See, amount of liquid phase at point M is MP by OP. Liquid phase MP by OP. Okay. So I have to draw a tie line first of all to find the relative amount of the phase. To apply the lever rule, I need to apply the tie line. So that tie line will be done by drawing the line perpendicular to y-axis, okay, till the solidus curve. Draw the line perpendicular to y-axis till the solidus curve and mark the points on the liquidus line. Point M is anyway mentioned, and point P on the solidus line. So with this line, tie line, I will apply the lever rule and find the relative amount of the liquid and solid phases. Okay, hope you got it. And how the numbers, that I think you will find out from the graph. Like MP means 60 minus 31. MP 60 minus 31. Okay, now this again you can follow anything, either you take A or you take B, it is up to you. I mean to say the points, like here MP 60 31 means they have followed it as per A, percentage of A, that is why it has taken as 60 minus 31. You can take also B, not a problem. You'll get the opposite answers, that's all. That is all the difference. Okay, so it's up to you. Better you take from A, easier to understand. Okay, so that is relative amount of the solid liquid phase. Okay, next is composition of the phase present. Composition of the phase means you know there is liquid and solid phase, but that solid phase, in that solid phase, how much percentage of is A, how much percentage is B? In liquid phase, how much percentage is A, how much percentage is B? That you will be finding out in this. To find that out, you have to draw perpendicular line to x-axis. Draw the line perpendicular to x-axis from O and from P. The line dropping perpendicular to x-axis from the liquidus curve tells you the liquid phase, and the line dropping perpendicular to x-axis from the solidus curve tells you the solid phase. So here point S represents the composition of solid phase, point L represents composition of liquid phase. So that will tell you whatever the point it reads, 31%, 69% B, 73%, 20, that you will get directly from the graph. Okay, so don't get confused relative amount and composition of the phase. When you say relative amount of the phase, it means amount of liquid phase, amount of solid phase. When you say composition of the phase, means how much percentage of metal A, metal B. Composition means how much of metals are there. Okay, so don't get confused. So the relative amount is by the lever rule, and composition of the phase you don't apply lever, you will get directly from the graph. Clear? So that is finding out for the combination of 60% A, 40% B at 1250 degrees Celsius. Now similarly you are supposed to find out for the room temperature. Again, getting back, you are supposed to predict the number of the phase for 60% A, 40% B at room temperature. That means 60% A, 40% B at room temperature. Say I take it as 25 degrees Celsius, room temperature. So where is the point? Point R. It is in this region. What is this region? Region below solidus curve. Region below solidus curve is all solid. Why? Again, I have explained this in the previous video. Please follow that video. Okay. So this complete region is solid phase. My point is, in this phase means it is only solid. So what is the number of phase? How much is the number of phase? Means it's 1. What is the type of phase? Means it's a solid phase. And what is the relative amount of the phase? It is 100% solid phase, because there's only one phase. And what is the composition of the solid phase? It is 60% A and 40% B. Get it? If you have not understood this video completely, it is okay. the same thing I have given, like the solved problem is also there in the slides. Please follow the slides, also this video, you will definitely understand. Okay, so this is type 1 problem under problems of phase diagram. Type 2 I will be discussing in the second video. Please follow the previous videos and get back to this, or else it will be difficult for you people to understand. Okay, hope you're clear with this. Any doubts, please let me know in the WhatsApp group or elsewhere. So thank you, and wait for the next video. I will be discussing about type 2 problems of phase diagram in the next video. Thank you.